Next, so if you'll see here, fourth property, like so many properties we can write, but just I will say you. So you'll study in later in 11th or 12th, you'll study. So as we know that these cathode rays are moving very fast, extremely high. So that definitely they will produce some kind of heat energy. Is it yes or no, guys? Clear, all of you? So that is the reason it will cause us to increase in the temperature. So I can say cathode rays cause heating effect. That is the fourth property. So because of fastness, they will travel very high speed. So as they are having the mechanical energy, we know with physics we studied. What do you mean by mechanical energy? Everybody? Yes, please.
Kinetic energy,
Kinetic
potential
energy,
energies.
potential energy together we used to say mechanical energy. So as they're traveling very fast, all of you remember they're having what energy? They're traveling very
Kinetic.
fast. They will possess kinetic energy. So these kinetic energy transferred into the heat energy when they will strike the walls or any kind of object. So it will increase. It will cause us to increase in the temperature. So that is what we can say. Cathode rays cause heating effect because of their kinetic energy. So that is what you have to remember. Next, you can see you might be heard in class 10th chemistry will study. How many of you know photographic plates like a films? Nowadays we are capturing the memory only. Olden days and all we are having the films. Have you noticed it? Reels we can say. Please respond. Have you all knows that? Yes, please. Photographic
Yes,
plates.
sir.
If you put in Google, you'll see that photographic plates. Okay. So if these cathode rays, if it will falls on this photographic plates, they will affect. Means reaction will takes place. So photographic plates, you might be notice it. Olden days we can used to see that. Still, of course, nowadays also we can notice like a reel. Have you noticed it or not? All of you? Yes, please. Nowadays we are capturing with the memory.
Yes, sir.
Yeah, well, nowadays we are capturing with the memory. But olden days we can see negative, so we can say that like a reel it will be there. Middle, if you'll see your photo will be visible. Later, after washing with the chemicals, we will get our proper photo. Have you noticed it, guys? That is what. So
Yes.
cathode rays, if this light will falls on these photographic plates, they'll be affected whenever we are exposing to the cathode rays. So that is what it is a defect of it. Even for destroying and all, we can use it. Okay. Next, these cathode rays. If you'll go to hospital, you might be heard about X-rays. Have you heard about X-rays? X-ray. Yes,
Yes,
please.
sir.
Yeah.
Yes.
So, all of you remember these X-rays, how they are produced. Even this question in quiz I answered wrongly. Sun rays consist of only visible light, infrared light, and UV light. But I thought it's X-ray also. Even I know, but I did mistake in that. So it is not. So these X-rays are producing. How you know, guys? With the help of what rays? Cathode rays only. Clear? So how it will be produced? Observe. So you can make cathode rays produces X-rays. Cathode rays produces X-rays. How means when this fast moving, as we know, they are very fastly traveling, very high speed. So this fast moving cathode rays strikes on a solid metal like copper or tungsten, or we can take molybdenum. So it will cause us to produce which rays, guys? Yes, please. It will cause us to produce X-rays. Clear? So whenever this cathode rays will strike like these metals, then the light coming from them only we used to call it as X-rays. That is how even the X-rays are produced in our hospitals and all. Next. So what is the normal light speed? Anybody can tell me? Light speed. I want to know that. I have taught you already. What is the light speed? Yes, please. What is the speed of light? Normal light, guys. Nitakshri? 3 into 10 power 8 meter per second. Do you remember that? Any one of you? Speed of
Yes, sir.
light 3 into 10 power 8 meter per second. So this cathode rays also almost travel with the same speed of light. Okay. So cathode rays travel with a speed nearly equal to light. So please remember that. So what is the speed of light? 3 into 10 power 8 meter per second. Please don't say after studying the property that light will travel with the, cathode rays travel with the speed of light, but we don't know speed of light. So what is the speed of light, everybody? Yes, please.
3
3
into
into 10
10
power
power
8
8
meter
meter.
per second. You have to know it's a very basic value. Clear? That is charge of electron, charge of proton. These all the things by class 9th itself we have to know that. That is what everybody's expectation. Do you remember, Hari, charge of electron they asked in the quiz also? Yes, please. You might be remember that.
Yes,
Yeah.
sir.
So 1.602 into 10 power minus 19 coulombs. That is the charge of an electron. Okay, so please note that. So these all are the properties. So how many properties I told now? So otherwise, so many properties are there. So we can go with that, but it's not necessary now. So that is what it is. So finally, remember, cathode rays can ionize the gases. That is the most important one. So that is what I want to say. So this property will helpful for us because we all knows that ionic bond, we studied in chemistry. What do you mean by ionic bond? Yes, please. Ionic bond and as well as covalent bond. You have been studied two things. Can anyone tell me? Abhirami, Gokul, covalent bond and ionic bond. Covalent bond will form by sharing of electrons and ionic bond will formed by donating and as well as what? Receiving,
Receiving.
or we can say accepting electrons. So remember, these cathode rays can ionize the gases. What do you mean by that? Let us make it clear. So you can write it. For example, if you have taken any kind of gas, let me write please, all of you. Cathode rays can ionize gases. Okay, so means in the sense of gases get ionized when they are exposed to cathode rays. Means they will lose the electrons. That is what it will be happening. So if you have taken, for example, I don't know the gas name, just I am taking as a X2. So this is what the gas, unknown gas. So if I expose it to the cathode rays, all of you remember, if I expose it to the cathode rays means what, guys? Negatively charged or positively charged? Negatively charged.
Negatively charged.
Okay, the gas lost its electrons so that it will be see that turns into ionized. Have you noticed it? It turns into ionized or not? Positively charged particle. Yes or no? Yes, please. So that is what it is. See, X2, it turns into X2 plus, means loss of electron will be takes place. So that is what it will be happening. So cathode rays can ionize the gases. That is what it is. Okay. So this is what a general properties. How many properties I told totally? Please. Five? Five or six? Sanjay?
Five, sir.
Five properties. So we can study in higher classes so many. So by the time you will study, it's not necessary now. So you can go with that. So these are the properties of cathode rays. Of course, at least you might be remember 2-3 properties so that it will be good. At least we'll be having little more advanced than everyone. So now let us make from this all the properties of cathode rays and this experiment. Mr. J.J. Thompson made some conclusions. That is what we'll study now. So please, all of you make conclusion derived by Thomson. Conclusion derived by Thomson. Okay. So first of all, what is the conclusion made by Thomson? Anybody can guess? What is the charge of cathode rays? Mr. Nimish? Akilan? Yes, please. What is
Negative.
the
Negative
charge?
charge.
Everybody? They are made up of
Negative.
negatively charged particles. That is what we can say. Negatively charged particles only we used to call as what? All of
Cathode rays.
electrons. Okay. Cathode rays are made up of negatively charged particles. Umar, are you there? Kaushik? Negatively charged particles are electrons. So please write. Second point. Yes, please. Next. So all atoms consist of these negatively charged particles. That is what we can say electrons. So that is why electrons are the fundamental particles, fundamentals of particles. Write it. All the atoms consist of all the atoms consist of these negatively charged particles. Charged particles, electrons. So that is why, therefore, we can say electrons are the fundamental particles. Clear, everybody? So these are the conclusions. In future, you will study one more conclusion also. So based upon the properties. So now it's not needed, so that I am not stressing on you people. So next one. So we'll go to the next one, everybody. So keep by this all the things we have been right now. We are going to study properties of electrons. Very, very important, Amma. So you all should know these properties of things. Write it. Properties of electrons. First one. Electrons are negatively charged. Electrons are negatively charged subatomic particles. The charge on one electron. What is the charge of one electron? Anybody? Just now I told you. Charge of one electron. Everyone.
So 1.60
Please
something.
remember as it is negative. So basically we'll never represent minus, but you can write it exactly. 1.6 into 1.6 into 10 power minus 19 coulomb. That is what. Next. Mass of electron is the mass of electron is 9.1 into 10 power minus 31 kg or 9.1 into 10 power minus 28 grams. That is what it is. Please remember. Mass of one electron. Next. The mass of one electron is the mass of one electron is 1 by 1840th. Remember, 40th the mass of hydrogen atom, or we can say 1 by 1840 U or AMU. What do you mean by U or AMU? unified mass, or AMU means what? Atomic. What do you mean by AMU? Last chapter you studied, correct? AMU means
Atomic mass unit.
atomic mass unit. U means unified mass. The both are same only. So, what do you mean by this one? Anybody can tell me? What do you mean by that? Means in the sense of one hydrogen atom equals to how many electrons? If I have taken, so for example, beam balance, if I want to measure that mass of one electron, sorry, mass of one hydrogen. So how many electrons I have to keep, Hari? Suppose if I have taken like this beam balance. Yes, Mitakshri? So here I keep one atom of hydrogen. So one atom of hydrogen means here how many electrons I have to keep? Everybody? 1040 electrons. Then only their mass will be both the sides, it will be balanced. That is the meaning of it. Are you clear, Mr. Gokul? Akilan?
Yes, sir.
That is why mass of electron is negligible. Is it okay? Or understand everybody? Why the mass
Yes,
of
sir.
electron is negligible? Because of this is clear. Understanding, everyone? So that is what it is. We can say. Next, the electrons in an atom are present outside the nucleus. The electrons in an atom are present outside the nucleus. So they are called extranuclear particles. Extranuclear particles. Remember that. Clear? Next. So third chapter you studied last concept. Can you tell me what is the concept? Numericals will get it. Anyone? All of you? Last concept we studied in the last chapter. Anyone?
Mole, sir.
Mole concept. Very good. So you can say the charge on 1 mole of electrons, the charge on 1 mole of electron, the charge on 1 mole of electrons is called 1 Faraday. Please remember that. Michael Faraday, you'll get it in higher classes, electricity. So 1 Faraday. So if I say 1 mole of electrons is discharged, means it is equal to how many Faradays? 1 Faradays.
1
Okay. Next. Last point. The nature of all electrons is same. The nature of all electrons is same. Okay. They have the same masses irrespective of their, that means they have same masses irrespective of sources. Is there anything doubt till here? Abhirami?
No, sir.
That is what. So you all should know that fundamentals thing. Even I think Hari, the picture on what is that name called as guessing. In that round, subatomic particle came. Do you remember that, Omar, Sanjay?
Yes, sir.
Yeah. What is the name? What is the name of that? That picture.
So that where I with the picture, sir.
Yes. In that it came. Yes or no?
Yes, sir.
That is what. So these are the properties of electron. So remember, that is why from all these properties, now I'm going to make a definition for electron. So that is what we'll write it now. So please write. So based upon all these 6 properties, an electron can be defined as the fundamental material particle of an atom or subatomic particle which carries unit negative charge. What is the unit negative charge? Anybody? What is the charge? Charge. That is what? Minus 1.6 into 10 power minus 19 coulomb and negligible mass. What is the mass, Amma? Negligible mass. By this time, you all need to know 9.
1 by
Power minus 31 kg. Clear? That is what is electron. So if anybody will ask from today, you can say this is what is electron. So don't say electron means negatively charged particle. So you have to know the scientific definition, everything. So this is all about what is history of what is electrons and what is cathode rays, who has been discovered, how has been discovered. These are all the things. Anyone having anything doubt, you can ask. Clear, guys?
Yes, sir.
That is next. Next, we'll go with the discovery of protons, and protons we can say another kind of rays. What is that rays we used to say? Anode rays. Okay, so please write discovery of protons and anode rays. Okay, so as we all know that J.J. Thomson proved the existence of electrons. Now, so scientists thought that there must be some positively charged particles. Surely it will be there. Okay, in addition to electrons in an atom, to maintain the neutral nature. As we all know, atoms are neutral. Because what? If it is a negative charge, surely who must be there inside? Everybody? Who must be there?
Positive.
positive charge.
Positively charged. So that only when once the J.J. Thomson proved that it is a negatively charged particle, electrons are present in an atom. So then all the scientists thinking over that, surely some positive charge will be there. So what is that positive charge? Let us analyze it and where it is located and all. So, with that thought only, in 1886, year of 1886, a German scientist called as Goldstein, Eugen Goldstein, we can say his name is. Eugen Goldstein performed an experiment. That is what we can say. Mr. J.J. Thomson, what is the tube called as? Anybody? J.J. Thomson, what tube? Yes?
Tube, sir.
Discharge tube.
Or cathode tube, we can say. Same way, Eugen Goldstein performed an experiment in Cork's tube. Okay, it is also similar to that only, Cork's tube, in which a beam of positive ions were created. Okay, so that is what it will leads to the discovery of protons. That is how he has been find a positively charged called as protons. So this Kurz tube, how it will be present and what is this? This all we will be studying it. So he is also a 19th century scientist only. He was born in 1850 and died in 1930. That is what he is, and he is the one who has been discovered these protons called as anode rays. Okay, so let us study experiment conducted by Mr. Eugen Goldstein, how he has been there and what is the conduct. So let us discuss Just let me show you first now. What is this cork tube? Okay, CRO, yeah, cork tube, and how it will be there now. Okay, so let us see that first. It will be similar to the same thing actually, discharge tube only, but it will be showing the different. That's all we can notice it. So I will show you. I am not finding any exact pictures. Sure, okay. So here, we are not finding. So let it be. I will itself will try to draw so that you will understand. So please, all of you draw the first a schematic diagram of cathode tube and as well as production of anode rays. We will study now. So you can take normal tube. So here we'll connect it to the something. What is that called as? Anyone? Before also you have done. It is vacuum.
Vacuum pump.
Vacuum pumps.
Okay. Now here will be the anode. Please all of you remember. This will be the anode. So anode means what charge? Positive. Clear? So high voltage is connected. High voltage source. Positive or negative? Yes, please. Positive or negative? Anode. So now here, yeah, here we will create a, that is what we will create a negative cathode. So a cathode which will be having negative charge. That is what we can say perforated cathode. I will explain it, don't worry. Okay. So now if you have been connected this, so here if you have noticed, what will happen means at this wall we will see the reddish color light. Reddish color light. So that is what opposite to the which one? Have you noticed it? Opposite to the whom? Yes, please. Anode. Clear? That is what I want to say. So that is why we used to call them as anode rays. Okay? High voltage source. Now, here we can see a red fluorescence is produced. Here by anode rays. So, but cathode rays will produce what color? Opposite. We all knows. What color?
Faint.
Greenish color. That is you have to remember. Okay. So that is what it is. A greenish glowing light. Produced by whom, guys? Cathode rays.
Yeah.
Cathode rays. That is what you have to remember. So from this we can write towards to it cathode rays. So that it will produce what rays? What color light? It will produce greenish color light on it. Because it is a what, guys? Anode or cathode? It is cathode. Okay. That is what negatively charged. So next from here it will goes. So what is this rays called as? Positively charged rays. What is it called as? Anode ray.
Anode ray.
That is what you have to remember. Understand or?
Yes, sir.
Okay, this is what it is. So let us see that how this cathode and anode rays are produced. That is all we'll discuss now. Experiment alone we'll study. So use an gold stain, use a discharge tube having perforated cathode to produce anode rays. So what do you mean by this one? We'll discuss. So when this tube was connected to about again the voltage, can you tell me what is the voltage has been taken? Everybody? Again the same thing. What do you mean by voltage? Everybody? Please respond. What do you mean by voltage given? What voltage how much given? Mr. Jaya Thompson.
10,000 volts, sir.
10,000 watt. Understanding? So same 10,000 volts has been taken with the perforated cathode. So please all of you write first meaning of perforated cathode. Write it. So what do you mean by this perforated cathode means having the holes cathode with the holes, that is the meaning. Before we have taken the cathode means one rod like this, understand? Now what do you mean by perforated cathode means if this is the cathode, we will make a holes for it. That is what we used to call as perforated cathode. Are you clear, everybody? Yes, please.
Yes, sir.
Yeah, that is the meaning of it. Please remember that. Okay. Now let us understand it. So you might understand how it is perforated cathode. So he has taken a discharge tube having a perforated cathode. So then only it will produce just what? Anode rays. So when this tube was connected about 10,000 volts source, a very dim luminous rays were seen extending from the holes of the perforated cathode, very dim luminous rays. That is what is the color actually? What is the color? Red in color. Clear? So these rays were moving exactly opposite to the cathode rays. So as we know, cathode rays will move from where, guys? Cathode to the anode or anode to the cathode? Cathode rays. Mitakshri, cathode rays will move from where? Cathode to the anode or anode to the cathode? Cathode rays moves from
Cathode to
Cathode
anode,
to
sir.
anode, sir.
anode. So here, when we connected 10,000 volts to this perforated cathode, okay, so we are noticing a dim luminous rays, and they are seeing from they are noticing that they are moving exactly opposite to the cathode rays. Means they are coming from where? They are coming from where? They are coming from the anode. Understanding? So that is the meaning. So that these rays were exactly moving opposite. You can see that this is called as cathode rays. They are moving like this, but these are moving opposite to that. So that is what he has been known. So Goldstein concluded that these rays were composed of what charges, guys? Anybody? What charges it is? They're
Positive charge.
positive charges. That is what he is to called as. What is that called?
Anode. Anode ray.
Okay. So now, if you have noticed here, he named these rays as it is. They are moving opposite to this cathode rays. He has called as canal rays. What is the name has been given this?
Canal rays.
That is what is the name given because as they are moving through the holes of this cathode. What is the holes of this cathode name called as? Anybody? A cathode having the holes. What is
Perforated cathode.
Yes, perforated cathode. So as they are passing through the holes or channels present in the cathode, he used to call them as canal rays. So that is why. But if you see that actual nature of this particle of canal rays not discovered by this Goldstein, he has been again. It has been found that 1907 when these rays were treated under the magnetic field, then only it has been revealed that these are positive charge, but they are not having the same mass. That is what the properties which we will study. So once as they are passing opposite to the cathode rays, that is why as they are passing through the canals means these holes, or we can say can you hear me, everybody?
Yes, sir.
Yes.
Yes, sir.
So now, as he noticed that some colors of light is forming at the anode, cathode behind, and exactly they are passing opposite to the cathode rays. So as they are passing through the holes of this cathode, holes, or we can say that canals. That is why he called them as what rays? Is to called as canal rays. Clear? And later in 1907. And in this year, these rays were treated under the magnetic field. Then only they have been found that they are not